Good morning, everyone. So let's have a brief review of what we have discussed so far. We said that in R, we can, R recognizes several types of data. So you have numeric, you have integer, character, logical, complex, and date. So we discussed this in the past sessions. Numeric, by numeric, we mean it can accommodate decimal places. Okay, and for integer, it does not accommodate decimals. Okay, this is very important because in as far as providing precision to a number, okay, of course, integers are less precise because they do not carry decimal places. While numeric, that's why the type of is called double. It has something to do with the precision, with the number of decimal places it can carry. Okay, so characters always have quotes, either single or double. Logical can be written as true, all capitals, or okay, just the first letter. Or false, or the first letter. Then we have complex, which consists of the real number component and the imaginary number component. Okay, so we said that R is all about objects. Okay, you can create objects by denoting it by a variable name. The variable name can be alphanumeric, but it has to start with a letter. Okay, you cannot create an object starting with a number. Let's say 1A. If I do that, 1A, assign it to 100. If I try this 1A, okay, there will be an error. Okay, it will not recognize that. Names can also not have, it cannot have spaces. For example, A1. Okay, so again, A space 1, that's not also acceptable. It's error. If you want to use both, you can use A and then underscore 1. Okay, this will be acceptable. Okay, so now we have A underscore 1, or put them together, A1. Okay. All right, so these are just simple rules in giving names to objects. Okay, and of course, it's the best practice is make the name understandable enough so that you know what that object consists of. Okay, so there are several ways to print your object. One way is just to type. Okay, for example, here we have this object A1 and it consists of 100. And sorry, by the way, any object that you create will be reflected here in your environment. So it depends on the object that you create. If it's a vector, it will fall under values. Otherwise, it will fall under data, which we're going to see in a while. Okay, so how do you print A1? Well, you type A1 and then enter it. So it will print the output here. Or if you're creating an object, okay, let's suppose we go back here. How do I go back here without typing this? Okay, you just press the up down arrow key there. Okay, it will go back to the previous codes that you wrote. Okay, because you cannot highlight this. Okay, or you cannot, you cannot go back here to this particular code chunk, or you may just highlight it and copy it. But one way is to just use the arrow key, up, down arrow key. Okay, so here, how do we print this? The shortcut is just to enclose that code, that assignment into with parentheses. And then when you run this, it will automatically print the value. Okay. We said that this has a name. This is your assignment operator. Of course, we can use A1 is equal to 100. That's also acceptable. Okay, you see that A1 was created. And when you create, by the way, when you create A1 is equal to, let's say, 200, this will supersede the previous A1. So currently A1 is 100. If I press A1 is equal to 200, now A1 has become 200. So the other A1 has been superseded by the new A1. Okay. Then we said that we can determine what's the class of a particular object. Okay, so it's a hierarchy. First, you can take a look at the mode. So let's take the mode of A1, and we know that A1 is numeric. And then, so the mode gives us it's more of the higher classification. Then a subclassification is a class, A1, it will give us still numeric, and the much lower classification, which determines now the precision that's needed for the object in that variable, for the element of that object, type of A1. We know that this would be, type of, I forgot, of A1. Okay, and it's double. And as I said, double has something to do with the number of bytes that is reserved for that specific object. So it has something to do with precision. If we're dealing with integer, the mode will be integer, the class will be integer, the type of will be integer. Okay, so no change. It's only in numeric where you have this type of distinction between the type of and the class. Okay, so here we have this object B. Okay, and it's an integer. If I run this, okay, B, and then let me just also run mode B, and then let's also include here. Let me include also type of B, and then class of B. So here we have actually three different instructions for our three different codes. Okay, so we'll have three different answers here. All right. So number one, B, it printed 3. The mode, as I said, is a broad classification. Now, integer is also, in a sense, numeric. It's a number. Okay, so that's why in the mode function, the integer is also numeric. And then when we take a look at type of, it's still integer, and then class is integer. Okay. All right. Let me pause for a while. May I have your confirmation if these are clear so far? Kindly chat, please. So far, this data type of numeric and integer, is it clear? Thank you. So let's wait for the others to. Thank you so much. I appreciate, class, your responses. Okay, for some of you, this might be too elementary. Please hang on. Okay, this is for the benefit of those who have not yet had some experience with R, but we'll get there. By next week, we will start really with the meaty stuff. Okay, thank you so much for your response. Okay, now for the date, okay, dates are very important as far as R is concerned. We'll have some examples. Hopefully, if we reach that part, we'll have examples of that. Okay, so as far as data structures is concerned, we said that, okay, there are several types of data structures. We have vectors, we have lists, matrices, arrays, factors, and data frames. In this subject, we will deal mostly with data frames, but it's important to know the distinction between these types of data structures. Okay, here I gave you here some functionalities on understanding the nature or the attribute of a particular object in R. So we learned about class, type of, mode, names. Okay, let me just give you a brief example of names. Okay, if you recall, what package is used? What's the most let's say popular package as far as data visualization in R is? May I have your answer, class? Could you kindly type? What did I mention was one of the most popular data visualization package in R? Yeah, thank you, Matthew. Thank you, Igo. Yes, you're correct. How about the others? I hope you can also respond next time if I ask a question. Yes, that's true. GGplat 2. And then, am I correct that I already taught you how to install a particular package in R class? Have we discussed that in class? Okay. So that's from the other section. How about from the other section? From FINLYTS K32. I got the answer from K31. K32, may I have your confirmation if we... Not yet, Julian? Okay. All right, so I haven't taught you how to install packages. Okay, so let me briefly go to that. Very sorry for that. Okay, so how do you remember packages are programs that people who know how to program in R have written in order for it to facilitate the let's say the programming, the data analysis using R. And there are to date, I think more than 20,000 already packages that have been contributed by several authors. So what they do is that they submit this to CRAN, the Comprehensive R Archive Network, and then CRAN vets it. And then once it's accepted, then it's posted in the repository of CRAN. Okay, so we can only access the functionality of a particular package if we install it. So how do we install packages? For a package, if it's stored in CRAN, it will be very easy. So one way is to type this install.packages. Okay, if I type that install.packages, you can see that with the IntelliSense, it will automatically type for us possible functions. So you don't have to type everything. Once you get, for example, when you say install, okay, even at this point in inst, okay, just typing inst, you can already see the possible functions that you may use. So the first one here is install packages. So I can just press tab. Okay, so that's a shortcut. And then the package that we're going to use is GGplat2. This is a very important package for data visualization. So you have to run this. Okay, I won't run this anymore. Okay, because it's already stored in my machine in my computer. So let me give you a few seconds to run this, install that packages. Okay, and then please chat if you have already installed the packages. For those of you in K31, I think we have done this. So you can just type yes if you have already GGplat2 installed in your computer. Okay, thank you. Right, waiting for the others to, yeah, thank you. Good. How about the others? I can see only 6. Okay. Okay, waiting for the others to respond. I hope I get 100% participation from the class. Okay. All right. Thank you so much. Although I think I haven't gotten 100%, but it's okay. Next time, please participate. All right. Okay. Now, how many times do you have to install a package? Okay. You install it only once. Okay. By the way, before I go to the next one, this is one way to install package. Another way is here under tools. So under tools, you have this installed packages. All right, so this will appear. Now, if you take a look at this install from, okay, this is what I mean repository from CRAN. Okay. And then there are all the others also from package archive, but we will just first go to CRAN and then you type ggplat2 here. GGplat2. Okay, so this is another way to install your package. And then when you install it, the function install that packages will appear here. Okay, so let me do this, install. Okay, and then it asks us one or more of the packages to be updated are currently loaded. Okay, so it's asking me to restart, so I won't do that anymore. Cancel ko na lang. Okay, so once we have done this, another way, by the way, there's another way. You go here, packages, and then install. Okay, same thing here as the tools. Okay, you get the same dialog box here. All right. So several ways to install a package. So once you have installed it, it should appear already here. Okay. If you go to your packages and then if you type here in the search, just let's see. Okay. So let me go back and then I'll type GG. Automatically, it will give me those packages that I have already installed in my machine, starting with GG or about GG. Okay, we might have different items here because maybe you haven't installed GG45 or RAGG. Okay, so we can now see here that GGplat2 has already been installed. Okay, if you want to learn, let me just close this first. If you want to learn what GGplat2 is, the help function in R, just by clicking this, will give you very, very good information about what this package is all about. So you have here the description file. Let me click this description file. Okay, it gives us some information about this package. So the package is GGplat2. The current version is 3.4.0. And what is this package all about? It's to create elegant data visualizations using, okay, GG stands for the grammar of graphics. So this was developed by Hadley Wickham. Okay, he's the promoter of this method of plotting data. Okay, in R, you have at least, if I'm not mistaken, you have 3 methods of plotting data. You have the base method, okay, and then you have the lattice method, and one of the most powerful ones is the newer one is the GG method, the grammar of graphics. So what Hadley Wickham did was to create a grammar, a syntax for plotting data, wonderful, beautiful data visualizations. Okay, so now I think there are now, because GGplat2 has gone through several evolutions, 3.4 na ngayon. Tapos there are those who are already helping him. So you can see here there are different persons now who are also involved in the improvement of the package itself. So si Winston Wang, he's quite popular in the data science field. Also Lionel Henry, Takahashi, I've heard of him, but the others, Karawu, not so much. But these people, the first 4, are very popular as far as data science body of knowledge is. Okay, so what's a description of this package? A system for declaratively creating graphics based on the grammar of graphics. You provide the data. You tell GGplat2 how to map variables to aesthetics, what graphical primitives to use, and it takes care of the details. So you can see here 3 processes, 3 steps, 3 basic steps. Number 1 is identify the data. What data do you want to plot? And then tell GGplat how to map the variables to aesthetics. What does this mean? It means that for example, a data set may have several variables, and you have to define what variable you want to plot. Okay, so you have to tell R, okay, I'm going to plot variable X and variable Y. And then you tell R, what type of plot do you want to use? Is it a scatter plot? Is it a box plot? Is it a violin plot, etc.? And there are many types of we call it graphical primitives to use. And then GGplat will take care of itself. Okay. So maybe no. let's go back here and let's see. All right. For example, I don't know if we can find a. Okay, let's see. Let's go to medium density. Okay, but it's long. I wanted to run something. Maybe this one. Okay, this one. We can do this. Okay, simple code. All right. So first, GGplat2 package also comes with. Okay, before I forget, when you install a package, you cannot automatically use the functionalities. Okay, remember this one. There are several functionalities here, and each one of these is a function. Each one of these is a code. It's a function that you can use in order to perform a a data plotting. For example, geom histogram. Okay, if I click this, then you can see here. This is the function. For example, geom frequency poly, or geom histogram, and you can see here the syntax. These are some of the this is the syntax that comes with geom histogram. Sometimes you might not need everything. Okay, sometimes you might need all. So it depends on what you really want. If I go here, example here. Okay, this one. This is just a very simple function, ggplat, and then you identify the data diamonds, and then object or the variable aesthetics or aesthetics, AES. This is the the x and y axis that you want to determine, and then plus the type of plot that you want to use, geom histogram. Actually, it's very easy. Okay, but of course there's a learning curve to it. Okay, as I was saying, once you have installed GGplat2, you have to first load it. Okay, GGplat2. You have to load it using library, or another way is, let me comment this out, require GGplat2. Okay, so these are two ways. Actually, there's another way. The other way is go here, packages, and then GGplat2. And then if you click this, let me click this. You see, automatically it prints this one. So this is the code. This is clicking this one is equivalent to library GGplat2. Okay. So now, okay, let me run that. Let's run that. And now you can have now the you can now make use of the functionalities of GGplat2. Now, oftentimes packages in. Okay, let me pause. Clear so far, class? Could you kindly chat, please? If am I going too fast? Are there any clarifications? Okay, good. Thank you. All right. Okay, oftentimes, R comes with, I think there are now 1,900 data sets. Next time, I'm going to tell you how to find what the data sets that come with R. In fact, let's do that. Data sets. Okay. Let's seek the help. Data sets. It's a package. Control Enter. Okay, it's still running. Apologies, class, because sometimes when I'm discussing a particular point, and then sometimes it leads me to one thing, and then I'm thinking that this is important to discuss. So let me just continue with this. Okay. Okay, so this is a list of sample data sets. You can see here AER. AER is the package. Okay, and then the name of the data is this one. So we can see here coming from AL, this time it's coming from ALR4. Let's see. The first portion there is your package. Let's see. For GGplat2, okay, here. So GGplat2, you can see here GGplat2, and then you have here two columns. What does this mean? That this one, whatever this, either a function or in this case a data, it's coming from GGplat2. So GGplat2, you have also economics data, faithful, GG proto. Okay, so several packages here, class, there. So from Lava package, you have this serotonin data, etc. So quite a lot. I think 1,900 plus data sets already. Not to mention the other data sets that are not yet recorded here because it's already a package, but it's not yet stored in CRAN. Okay, so these are just the data sets that's stored in CRAN. For example, Wooldridge. We will be getting some data set here from Wooldridge. Okay, and also let's see, quant mode here also, letter Q. This is the first software next week that will be starting to deal with quant mode. Okay, where's that? Here. Quandel and then quant mode. Okay, here, quant mode. So there are also several data sets that come with quant mode. Okay, so now that we have learned that R has with it several data sets that we can use for analysis. Okay, let's get one. So how do you get a particular? How do you load a particular data? So here I type data, and then you notice here these are the data that can be loaded coming from different data sets. Okay, so let's use diamonds. Okay, so how do you load a particular data and then quotes diamonds? Okay, if I enter this, control enter, notice that it's now under our environment, but it's not yet fully loaded. So how do you do that? You can type view. Okay, so I just started typing view and it's already placed here. So view diamonds. When we do this, view diamonds, control enter, it will generate this, okay, this tab diamonds, and it will give us the different variables that come with it, showing 1 here below to 13 of 53,940 observations, 10 total columns. So these are the number of observations, the number of columns. All right. So let me just give you a distinction. You notice here, you have data and then values. So I'd like now to point out that these are your vectors. Okay, I know that this is a vector because it's under values, and also we created this. Okay. However, this data, you can see that this is different because it has 53,000 rows and 10 columns. Vectors are just unicolumnar. Okay. Okay. Even if we create, for example, let's create A2. Okay, and then it's let's say 1 up to 100. Okay, so we have discussed that this is a integer vector. Okay, if I run that, okay, you can see here that it's an integer vector 1 up to 100, and it will fall under values. So everything that goes here are vectors. Okay, and vectors are a type of data structure that's atomic, which means that only one type of data. So if it's integer, then it should be integer. If it's character, then it should be character. Okay, etc. Okay. For diamonds, we can use the structure diamonds. It tells us what type of data diamonds is. Okay, so here you can see the structure. It's a table. Okay, table is a table data frame. Okay, it's a data frame table. So it tells us here that it's a data frame. Okay, which is one of the types of data structure. And as discussed before, you can see here that $carat, which means that carat is under this object diamonds. Okay, and you cannot access. I think we learned last time that we cannot get the mean. If I try to get the mean of carat, it will return to us an error term because R does not recognize the object carat. There's no carat here. So if we want to do a statistical metric, so you have to identify the object which R recognizes diamonds and then the $sign there. Okay. And once you get the $sign, automatically it gives us the elements of that data. So carat, and then we can now get the mean because carat is a numerical variable. Okay. So actually, I discussed that because there was a function here that appeared. Okay, names, no? So names will only be relevant for data frames. So if I type names here and then diamonds, okay, so what do we have here? Names, diamonds, it will give us the names of the variables or the columns that are present in diamonds. Okay, unlike names, for example, names of A_1. Okay, A_1 is just it's a vector of 1. Okay, 100. If I run that, it's null. Okay, names are for data frames. All right. Any questions so far, class? Kindly chat, please, if we're clear so far. Okay, none. Thank you. All right, good. Please feel free, class, to ask questions if you have any. Okay, so some other things here. Okay, how about attributes? What does this give us? Attributes, say diamonds. Okay, so in this case, it just gives us the names. Okay, let's see. So the attributes give us the number one, the class. Okay, so it's a table data frame. It's a data frame. And then it also gives us the row names. Okay, the row names are, so this is just the index, because if you take a look at diamonds, it doesn't actually have a row name. It's just the default index, 1, 2, 3, 4, 5, 6. Okay, it gives us the row names. And then below, so that's up to, okay, it was only able to print up to 1,000. Says here that it reached the optimal number, the maximum to print here, 1,000. So it did not yet print the row numbers from up to 53,940. And then the names. Okay, so the attributes gives us some information about our data. It's just like a metadata, data about our data. Okay. All right, then another thing. Okay, so just to be familiarized with the codes here, we have we already discussed the structure, and then let's see attributes also, and then dimension. What's the difference between dimension of? Let's first start with dimension of A2. Okay, dimension A2. Control Enter. Null. Okay, it doesn't have any dimension, but length of A2 is 100. So how many observations A2 does A2 have? A2 is a vector. Okay, so dimension is only used for data frames. Dimension of diamonds, so it's the number of rows by the number of columns. Okay, so take note of the distinction. Okay, what if I use length for diamonds? What will this give us? Okay, it only gave us the number of columns. Okay, if we want the rectangular dimension, you use the dim function, the dimension function. Okay, and the dimension will not work for a vector because vector, it's just one, whether you arrange it as a column or a row, it doesn't matter. Okay, so I think we have discussed all of this. No? Any questions about this one? Class, type of, mode, names, length. Okay, so these are just some of the functions that we can use in order to understand the attributes of a particular object in R. Okay, so here we said that a vector is atomic. It only contains the same elements. So this is a vector of 1. This is also a vector of, this is a numeric vector consisting of 1.13, negative 5.7. So if I run this, if I'm creating this object nums and I get the class, okay, it will tell us that it's numeric. Okay, it's numeric. Now, all right. May I? I'm sorry to ask this question. I'm not sure if in K32 we discussed the set.seed. Could you kindly confirm, class, please? If we already discussed the set.seed, I'm sorry. I sometimes I get confused with what has been discussed in a particular section. K31 and K32. Could you please confirm if we have discussed the function set.seed, please? Okay, thank you, Matthew. How about K32? FINLYTS K32? Okay, all right. Thank you so much. I knew we did, but I just wanted to be sure. So the set.seed allows us to generate the same set of random numbers. So this is what we discussed last time. I won't run this anymore, but this generates a vector of a numeric vector. Running our norm and identifying how many observations will give us a set of randomly generated numbers, which are normally distributed, and not defining the mean and the standard deviation sets it to a default of a standard normal distribution where the mean is 0 and the standard deviation is equal to 1. Okay, and we looked at the fact that we can. Okay, so let me just run this very quickly. Okay, all right, and then if I view devs, it will not give us it will not give us a worksheet like this. Okay, rather it just tells us that the type and the values, the first values. Okay, and we know that we know that it's a vector, 100 elements all in all. Okay, and then we can get the mean, of course, a standard deviation. And for the summary, it will give us the 6-number summary. Okay, this is just a quick review. And this is very important for plotting. Minimum, maximum, first quartile, second quartile, third quartile, and including the mean. Okay, and hist is a function for histogram. This is coming from the plots package. And as I said, there are several systems of plotting in R. The most basic is the plot system. So this function is from the plot system. Okay, if I okay, let me just check hist. From which package is it? Okay, it's from the graphics package. Okay, so we can plot this, and we did not load any more graphics package because it comes pre-installed with R. Okay, so to check, okay, indeed it looks like normally distributed. Okay, so let me move on because we want to. This is more of a review. Okay, and last time also we looked at the difference between writing your vector this way, listing it 1, 2, 3, 4, 5, 6 up to 10, as compared to 1 column 10. The difference between this, okay, I hope you still recall, this is a numeric vector, while this is a integer vector. Okay, this will generate an integer vector. This will generate a numeric vector. So let me just run. Okay, let's just run everything here. Okay, so the same elements 1 to 10. However, class G is numeric, class G1 is integer, type of G is double. As you know, pag numeric, ang type of niya, double. And then ang integer pa rin. And the length is both 10. Okay, so all right, then we have the, if you recall, yung coercion natin, no? What's the rule of coercion? Let's go back, let's go here. So you start with the most, say, primitive or the lowest rank data type, logical, then integer, then numeric, then complex, then character. Then the rule is that from a lower rank, it can be coerced into a higher rank, but not necessarily vice versa. Now, there are instances when we can coerce from character to logical. Take the case of, let's say, object A is true. Okay. And that's, of course, we know that the class of A is character. Okay, here I'm generating an object called A and its character. Okay, sorry, should be small letter A. A. Okay, so it's character. So we have A here. It's true. All right, now I'd like to create an object B, and it's as.logical. I'm going to coerce object A, which is character, into logical. Okay, so generally you cannot do that because character is the higher type. Okay, but in certain instances you can. So let me also type class B. So what I'm doing here is I'm coercing A, which is character, into a logical data. So is that possible? Let's create this object called B, and then let's run this. Okay, so see, B, and it's true, and it's logical. So we were able to coerce a character into a lower rank data. Okay, so there are exceptions to this rule. Generally, that's the rule. Okay, so this is the rule of coercion. But for some characters, okay, it can be reversed. Right? Okay, questions, class? Clear so far? Paki-chat naman please kung we're clear so far. Okay, thank you. Thank you. How about the rest? Yeah, thank you. Do you have any questions? Please feel free to interrupt me and ask questions. Okay. Now, I'm not sure if for the other section, for K32, have we discussed the sample function? I would appreciate you to confirm if we have done the sample function. Have we? This one? Not yet. Okay, good. Thank you. All right. So kindly create a code chunk. Okay, so let me first show what the sample function is. Okay, take a look at this sample, and it's from the base R, so that we don't need to install this package. Okay, so this is the simple syntax: sample x size replace is equal to true and probability. Okay, x refers to a vector from which to choose, or a positive integer. So which means that you identify first a vector, and then R will get samples out of that. Replace is equal to true means, okay, imagine you have a bowl of, let's say, ping pong balls, and those ping pong balls have numbers written on it, 1, 2, 3, 4, 5, 6. And then if you draw out one, let's say you draw out a number, for example, it contains 50 or 75, kunyari bingo, no? 75 numbers there from 1 to 75, and then you draw out one, and you draw out, for example, number 20. Okay, replace is equal to true means you can return that number, that ping pong ball, to the bowl, so that there's a probability, there's a possibility that you can still draw it again. On the other hand, replace is equal to false. Just like in bingo, when you draw out a number, let's say 52, you do not put it back. Okay, so that's replace is equal to false. And then probability is equal to some, depends. Okay, I'll explain when we go to we'll have analytics also for regression. We will be needing this in probability. Because in regression, as I mentioned, when you're given a data set, you do not use everything, all the sample. If you have 500 observations, you do not use everything, because you might encounter a problem called overfitting. So what we do is to split your data set and use this function sample, so that R will now get a sample. Let's say we'll split it into two. One is 80%, the other is 20%. So this is how it will be done. So that you have the 500 observations, 80% of that will go to one batch. That can be your training data set. That's what you're going to run. That's what you're going to use for your regression data. And then the 20% will be, after you have generated your model, you'll test your model and see if your model is still okay, even if it will now be run on a data set that it has not yet seen. Okay? Am I making sense, class? Paki-chat nga, please, if I'm making sense. Okay. It will become more clear when we have the actual project for that. Okay, so I'll just and you can have here, you can use this one as a sample, but let's now go to our sample. Okay, so so first let's initialize. Okay, let me delete this first. Let's create an object. Okay, let's call it ano na lang. Okay, Bing, no? For bingo. No? And it's from 1 to 75. Okay, and then we will create now. Let's set a seed, because sample is the sample function is randomized also. So let's set that seed, let's say 99. Okay, So let's create this object called sum, and we're going to use the sample function. Okay, the sample function, we're going to use this vector Bing, Bing. Okay, Bing has a 75, about 1 to 75 ton, no? And we'd like to generate 100, no? 100 observations coming from this. Ibig sabihin, you'll draw out lots, you'll draw out uh, the ping pong balls, okay, 100 times, and then of course replace is equal to true, because if we say replace is equal to false, once you get the ping pong ball, you cannot return it, so that leaves just with 74 ping pong balls there. So we cannot anymore draw out 100, right? So magkaka-error yan. Okay, so let's do that, no? Sabihin natin, i-false natin yan. Mag-error yan, class. And then let's just print the sump object in first 20. Okay, so let's run this. Run. Okay, error siya. No? Bakit error? Kasi ang sabi natin kay R, okay, let's create 100 samples. No? 100, you draw a ping pong ball. Let's say it's 15, and then you write 15. How can that be done if we're not going to replace the ping pong ball, di ba? Kasi 75 lang yan. Tapos you want to draw 100 times. Hindi pa pwede yun. So this has to be true, right? Which means that we should be able to return the ball, the ping pong ball, so that we can draw more than 100 or 100 exactly. All right, so let's run this. Okay. Okay, so we should have the same figures. No? 48, we just printed the first 20, 48, 33, 44. So you can see that these are all numbers from 1 up to 75. And R randomly picked up number, just like an experiment where we get the ball from the bowl, and then it writes down whatever number that is. Okay, may I have your confirmation, class, if we get the same first 20 values? Okay, good. We should have, because we used a set.seed function. Okay, all right. So I just wanted to this as an example because it will fall under your vector. So these are examples of vectors. Okay, so you can have character vectors. Okay, you can have logical vectors, but of course this one, this one cannot be. Okay, if we run this, okay, wait, kasi some of you might not, especially the others. I think I think we haven't gotten this far. Okay, may I know K32 if we were able to discuss this? Also K31, this, did we discuss this? Sorry, I wasn't able to jot down. My apologies. Next time I'll. Now I have already paper and pen to jot down up to what portion we discussed. Okay, so sorry. Ayan. Okay, good. So that's for everyone. All right, sige. Okay, so let's go back here. Okay, character vectors plus. So again, this is just a type of a vector which consists of all characters. Now we're creating this object I, and it consists of Monday, Tuesday up to Friday, but this will not run. Okay, if I run this, object Monday was not found. Why? Because we're creating a we're creating a character vector, and all character strings must be in quotes. So this one will now run. So Monday, Tuesday up to Friday in quotes. So this is okay. Okay. And as I said, if I want to automatically print the object, we use the parentheses. And then let's get the type of, this is of course character. Okay, so Even if we use mode of I, and then class of I. Okay. Okay, they're all characters. Just like for integers, the mode is numeric, the class is integer, the type of is integer. For a numeric, you have mode. What will be the mode class for? Sorry, for integer, the mode is numeric. The class is integer, and the type of is integer. Okay, and we have the length of I is 5. And as I said, we cannot use dimension for I because I is a vector. Okay, it's null. Nothing. It's not like a data frame. All right. So please create another code chunk, and let's take a look at this. So here I'm creating. Okay, maybe let me just share with you so that we can go. We can cover more. Okay, you may wish to copy this so that you don't have to type it. So here I'm creating this object X. And what do you notice about this? 1, 5.4, true, and hello. What do you notice about the elements of object X? Any comment, please? Any comment about object X, class? What do you notice about this? Okay, thank you. Yeah, Igor, you're correct. No? So we have numeric. This is also numeric. We don't have any integer here. No? We have logical and we have character. So we have 3 data types. You have numeric, you have logical, and you have character. There's no integer here. Okay, so if I run this, what do you notice? What data structure is X? If you take a look at this one, X here, it appears in our values, right? So indicating that this is a vector, but it's a character. Diba? When we had it printed, it was quotes, all in quotes. So what happened here? What happened here, class? Anyone? Something happened here. Yes, thank you. Yeah, Matthew, you're correct. They were coerced as character. Now, why character? Because we answered that question already. Character in this case is the highest rank data. Okay, you cannot create a vector in R that has the different data types. R will coerce it into the highest rank the highest rank data. In this case, it's character. Okay. All right. So what if we remove hello? Okay, let's see. So we now have, and let's put here 5L. Okay, we now have numeric, we have integer, we have logical. If we run this, okay, what happened? The highest rank now here is numeric, right? Numeric na siya. So it was coerced this time to a numeric. That's why the type of is double. And you can see here true was converted into 1 because true is also equivalent to 1. If this was false, then it would be, this would be 0. Okay, so let me put that back. Hello. Okay, so is this clear, class? So this is an example of coercing so that it will generate. Otherwise, it will not be able to create that object. But let me get ahead of myself. So I'll put here, let me copy this. Control C, Control V. Oops. So let's create this object called, let's say, Y. Okay. Is it possible for us to create an object where there's this combination of numeric, integer, a logical, and a character? Yes, that's possible if we, okay, if we insist on creating this, then we have to make it a list. Okay, so let's run this. Okay, so this actually brings us to the next data structure. Okay, here we're creating this one, 5.45L2 and hello, which is a combination of several data types, but it can be done because I'm stating here that it should be a list. Okay, and then when we printed this, diba? So the first one here, the bracket one is the first element of your list. First, second, third, fourth, fifth. Okay, so there are 5 elements in your list, and under that you have another subset. Okay, 1. Okay, which means that this is the first element of your list. Okay, let's add here, let's say C, comma C. Okay, let's say 2, 4, 6, 8, 10. Okay, so I added another vector here. Okay, Control Enter. All right. So I just wanted to illustrate, class, that, okay, the number 1 here refers to the first element, just like when we see brackets, when we print vectors. Okay, and it's a list. And where will a list fall under? If you take a look at this, now our data now consists of the diamonds, the data frame, and the list, which is Y. So if I click this, it will give us, okay, the print of the list. Okay, it's a list consisting of 6. Okay, and these are the elements of our list. 1, 5 point, it's a double, which is numeric. Then this is an integer. Then we have a logical value, a character, and a double, because this this is a vector also. So a list can contain a vector. Okay, a list can contain a vector. All right, any questions, class? Paki-chat naman kung clear. Okay, thank you. How about the rest? Okay, good. Thank you. Okay. So actually, we have learned 3 types of data structures. You have vectors. The most simple one is a vector. It's atomic. It can only contain one set of one type of data. Next, we have the list, which can contain several types of data at the same time. And a list can also contain, okay, a list can contain also another list, or it can contain a vector. So before we continue there, let's just finish this. This is a logical vector. Okay, you may wish to, let me just, okay, so that we can move faster. I'm going to share with you this so that in this case, don't have to type anymore. Okay, anyway, you already understand this, no? So that's why I'm I'm sharing the code itself. But when we're learning a lesson for the first time, I will not share with you the code. You will have to type it on your own. So here we're creating this object J. We're combining false and true. Of course, we know that this will return an error term, okay? Because it's neither a character nor a logical value. If we want this, then if we want this to be a logical value, we know that it should be spelled otherwise, all capitals or just capital F or capital T. If it's a character, then it should be enclosed in quotations, but nothing. So that's why it cannot create this object. Okay, for this one, this is okay. If you run this, okay, so it's a logical vector and the same here. So this abbreviation were read as false, false, true, true. So these are vectors, okay, logical vectors. All right. Now next, we can have operations performed in vectors. Okay, so let me again share this code chunk with you. Okay, so kindly copy that to a code chunk. So here we're creating a vector called numbers. So it's from 1 to 10. Let's run that. And let's take a look at the class of these numbers. We know that this is integer. And we know that this is the type of is integers. But the mode, let me just to remind you, numbers, the mode is of course numeric. Okay, numeric, yung mode, yung class is actually don't need to put here. Okay, sorry about that. You don't need to put in parentheses the function because it will automatically give the answer. Okay, so let's run this 3. Okay, it's only when you want to print a data that you put it in quotations, in parentheses, but not the function itself. All right, then if we create another number, let's create another. Okay, so let me share this again with you. In the interest of time, it's almost time. Bilis ng oras. I wanted to at least reach a data frame, but we might not be able to do that. It's okay. By the way, hindi, sa kabilang klase pala yun. All right, so we're creating another another object, numbers. Let's just make it integer na lang. 1 to 10. 1 to 10. Okay, again, no need for this one. No need for this one. Okay, numbers, all right. All right, so integer. Okay, so we can perform these operations for vectors. So let me once again share the code with you so that it be, you will just copy that in your code chunk. All right, numbers plus 2. The numbers vector consists of 1 to 10. Numbers ko pala, ano? Okay, gawin natin numeric no isa, sorry. Okay, as that numeric, kanina kasi integer siya, no? Ibahin lang natin. Let's check this. Okay, so numeric na siya. Okay, so numbers is numeric. Okay, take a look at what I did. Kasi this will generate an integer, diba? An integer vector. Pero, kino-erse ko as that numeric so that the integer vector becomes numeric. Okay, so we can, for example, numbers plus 2 So what happens? Yung numbers kasi 1 to 10 yan, di ba? Automatically nag-add ng 2 sa lahat ng elements. Okay, the numbers times the square root of 10. We print that. You can see here that yung numbers, yung 1 up to 10, each of them, we added square root of 10. So this is what happens when we have a vector and when we perform operations in that. If we add something, it will be added to every element of the vector. If we subtract or multiply or divide, everything will be performed on all the elements. Okay, here you're adding numbers 1 and numbers 2. Both are vectors, no? So 1 plus 1, 2 plus 2, etc. Okay, let's create here another vector called numbers 2, and then this consists of 1 to 6. If we run this, so 1, 2, 3, 4, 5, 6. Now let's add numbers 1, numbers 2, and create this object called num. Okay, Control Enter. All right, warning. Longer object length is not a multiple of the shorter object length. All right, so si numbers kasi 10, di ba yung length niya? Si numbers 2, 6. Okay, so the problem here is that yung numbers 2 has only 6 elements. Okay, but did it add? Yes, it added. Kasi andito yung num. Ayan, no? Num is here. That's what we created. Okay, so what happened? Yung numbers 1 kasi, 1 up to 10, di ba? Tapos si numbers 2, 1 up to 6. So what happened was, inad niya. 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4, 5 plus 5, 6 plus 6. But there are still remaining items here. Okay? So, from 6, bumalik siya dito. Nag-1 ulit siya. Kaya nga naging 7 plus 1. Okay? 7 plus 1 became 8. Wait, saan na to? Ito pala. 7 plus 1, 8. 8 plus 2, 10. 9 plus 3, 12. 10 plus 4, 14. So that's what happened. So pwede bang mag-add ng mga vectors kahit not of the same length? Yes. Kaso nga lang, we will receive this warning. Okay? We will receive this warning. Okay, but what if, let's say numbers 2 is just 5? 5 siya. So exact multiple yon, no? So ang mangyayari, 1 to 5, i-add muna, tapos sa next batch, i-add ulit yung 1 to 5. And we will not receive any warning here. Okay? Ito pala. Numbers 2 natin, 1 to 5. And okay, so no problem. No? Kasi yung 5, exact multiple yan ni 10. So umulit lang si 5, inad. No? Inad lang siya, inulit. Okay? All right. Pause again for a while. Any questions, class? Clear so far? Am I going too fast? Paki-comment naman please kung masyado ako mabilis, ha? Kasi hindi yun yung objective natin. Any questions? Okay. Let's wait for the others to give their comments. Okay, thank you. Although hindi pa rin tayo nakaka 100%. But thank you so much for your feedback. Okay. All right, so let's move on. Okay, so this is another okay, this is another function that we want to learn or even master. Yung sequence. Okay, I'll leave you class to search ano yung functionalities ng sequence, no? Sequence generation. In a nutshell, this will generate a series of numbers, sequence. No? So for example, let's make this All right, let me share this with you. Control C. Okay. So we have here sequence from 1 to 3 by 0.2. It means it will generate a sequence of numbers from 1 up to 3, and they will be equidistant from each other by 0.2. So it will be increments of 0.2. Okay, so let's run this. Okay, take a look at this. So the beginning is 1, the ending is 3. And they're equally spaced because we're incrementing by 0.2. Okay. Now what happens is, let's copy this. Control C, Control V. Let's sequence, let's say from 1 up to, let's say 5, and increment of 0.7. Okay, what will happen if we start with, okay, let's start with 0 to 5 and incrementing by 0.7. Let's see. Okay. So you find here 0, 0 0.7, 1.4, 2.1. Okay. So it was not able to reach 5. Okay. These are bounds, no? Up to 5. It only reached up to 4.9. Why? Because if we add 0.7 here, it will exceed the maximum value of 5. Okay. So that's why it did not reach 5. On the other hand, this one, so let's sequence from, okay, let's make it 10, 1 to 10, and length out is 8. Let's make it 8. What does this mean, length that out? It means that I want that from number 1 to 10, there should be 8 numbers all in all. So that's what the length that out does. No? Length that out. There should only be 8 numbers from between 1 and 10. Okay, so if we run this, all right, take a look. From 1 up to 10. Here you'll get exactly 10. However, you'll notice that the distancing, they're all equidistant. They're all the same. So let me copy this. Control C, Control V. Okay, let me just subtract and see what's the difference between this number and this number. So it's 1.2857. If I get this, Control C, Control V, and then minus, it's exactly the same. Okay. And lastly, about this one, is it the same? Is the difference the same? It's the same. Okay. So let's see if there are 8 numbers here. 1, 2, 3, 4, 5, 6, 7, 8. Exactly. 8 numbers. Okay. 8 numbers there. All right. So that's the sequence function. Okay. So this one is very easy. Okay, let me share this with you. Okay, we're creating an object called Q. Okay, and it consists of -3, -2, -1, 0, 1, 2. And let's print this. Okay, so this is the vector Q, can be seen here. And then here we're indexing Q2, which means it's the second element, and assign 0 to it. Okay, so we're replacing this -2 with 0. If we run this, okay, so you can see here it's -3. The -2 has been replaced by 0 because of this one. We modified the second element. Okay. All right. Then we can also delete a vector. Okay. There are different ways to delete a vector. For example, let me delete J1 here. So we have this J1, right? So I can use RM J1. RM stands for remove. So if I want this object J1 to be removed, okay, in my environment, I'll use RM J1. Okay, and see, J1 is no longer here. If I try to print J1, okay, object not found. Another way is to assign null to it. For example, this one, Q is null. So if I run this, okay, just to be sure, Q is still here, right? Okay, what happened? So it became null. Okay, so it's empty, nothing there. The remove function will literally remove it also from the environment. Okay, now let's see, Q plus 5. Okay, what happened? Let's create this object Q1, and then it will be equal to Q plus, it's almost time plus time na pala, no? Okay, so sorry, tapusin ko lang to, ha? I'm very sorry. Yeah, thank you. Yeah. So I'm creating this object Q1, Q plus 5, and yung empty siya, no? Tingnan nyo. No? So if I I created this object and I added 5 to Q, empty pa rin siya kasi null na nga ito eh. If I want to remove Q here from the environment, then I'll use RM. But we know that Q is actually technically non-existent na kasi ginawa na natin null. All right, so okay, let me stop there.